All right, so welcome back to everyone. A very warm welcome to all of you, my dear students. So I am your physics educator, Dr. Shankar Tripathi. And in this session, guys, what we are going to do, so in this session, guys, we'll be starting with the concepts of the vector. Okay. So from today's session, we will also be starting with the vector. So as you are aware that we are doing it the kinematics. So हम motion in a straight line पढ़ रहे हैं. We are seeing the motion in a straight line. And along with that, we are starting with the vector. So we have reached to some point in the motion in the straight line. Okay. Okay. So in that, what we have done till now. So till now we have done, differentiation, integration, their uses, the basic problems, average velocity, instantaneous velocity, average speed, instantaneous speed, distance, displacement. So all these things we have done, all these things we have done in the kinematics till now. Now I am also starting from today the vectors, the concepts of the vectors. Okay, okay. So because why I am starting? Because I want to start with the motion in a plane problems as well. Okay, motions in a plane problems as well. Okay, okay. So because the in one dimension also sometimes the concepts of vectors are getting used, and motion in a plane, so it is two-dimensional motion, uniform circular motion, all these things. So they will be keep on covering in this, in these vectors thing. Okay. So the live student can tell me if you can see me and hear me properly. Yeah. So I'm waiting for the live students to join. Okay. So I am Dr. Shankar Tripathi. I hope you guys know me. Right? Okay. Right. So let's begin with the session. So guys, first of all, so from this session we are starting up with the concepts of the vector. Very interesting, very useful, and very important. Because in physics, there are many physical quantities that are vector quantities, and when we'll be studying about them, basically we must be understanding about the basic operations in vector. Okay, okay. So let's start with that. What is the difference between scalar and vector? How do you understand a scalar quantity, and how do you understand a vector quantity? Right? Okay. So, sir, we know that some quantities are scalar quantities, some quantities are vector quantity. Now, if I ask you that how you feel the difference between the scalar and vector quantities, so what is the basic difference? What is the basic difference? So now many students say on this that the scalar is something which is having just the numerical value. So something if it is given by or completely understandable or completely defined or described by its magnitude or numerical value only, then we can say that it is a scalar quantity. It is a scalar quantity. So basically, scalar quantities are those which doesn't require any direction for them to express, right? On the other hand, so what is vector? So vector requires the numerical value, that is the magnitude. Okay, it requires the numerical value, that is the magnitude, and it also requires direction. Okay, it also requires the direction. Okay, so when you are trying to express a vector quantity, so along with the magnitude, the direction also is to be given. Unless the direction is given, you cannot explain any vector. So when the quantity requires both magnitude and direction, it comes under the category of vector. But this is not exactly the complete information. Okay. Okay. So it is only having the numerical value or magnitude. It having vector is having magnitude and direction. And one more thing is very important, that vector along with, so many students get confused in this. So and or they think this way, that any quantity which is having the direction and obviously having some magnitude is a vector quantity, but this is not a fact. This is not complete truth. There are many physical quantities which do have direction, but they are not vector. So one very necessary condition for any vector, any physical quantity to be called upon as vector is that it obeys vector law of addition. It obeys vector laws of addition. So what are the vector laws of addition? So vector laws of addition are like triangle law, parallelogram law, polygon law. So these laws of addition of the vector are necessary for any vector to be called upon as a vector. Okay. Okay. So those quantities, now please try to understand this. So those quantities which have magnitude, which have direction, as well as they obey or they follow the vector laws of addition, that is the law of triangle of vector addition, law of parallelogram of vector addition, polygon law of vector addition, then only that vector will be called upon as a, that physical quantity will be called upon as a vector. So don't forget about this. Okay, okay, okay. Now, the vector obeys vectors law of addition. That means that they are added, they are added, they are added to they are added by using vectors laws of addition. On the other hand, what is a scalar? So they are added, sorry, they are added, they are, what happened to them? They are added with the help of basic algebraic laws. With the help of the basic algebraic laws. Now, sir, how these things are different? See, understanding the basics of vector is very, very important. Then only you will be able to understand the addition of vector completely or nicely. Okay, okay. So they are added. Scalar quantities are the ones which are added with the help of basic algebraic laws. So, for example, let's suppose we have, time, we have mass, we have distance, right? Right? We have, energy, right? Etc. There are many scalar quantities. So if you see that time, mass, distance, so let's suppose I have 4 kg of something and 3 kg of something. Okay. I have 4 kg of something or 3 kg of something and 3 kg of something. So if I add these two, so these depends upon the magnitude only. So you are having 3 kg of fruit, let's suppose. So that 3 kg of fruit or 4 kg of fruit, does it have to do anything with the direction? Does they have to do anything in the direction? With the direction? No, sir. They have no relation with the direction. So they are the scalar quantities. Now, if you add them, you are going to always get 7. You are going to always be getting 7. So when scalars are added, you always get the same result. When two scalar quantities are added, no matter how and in what condition they are added, you always get the same number. Like for example, when 4 and 3 is added, you are always getting this 7. Are you getting my point? Are you getting my point? Now, let's suppose we are having some vector of 4 meter, let's suppose 4 units. Okay, so let's suppose this is a vector quantity. Let's call it A vector and let's call it B vector. Okay, they may be having some unit. Let's suppose they are velocity 3 meter per second, 4 meter per second. Okay, okay. Now please understand this. Please understand this. So if you are going to add these two vectors, okay. So if these are scalar quantities 4 and 3, so they are added in whatever condition, they always give you 7. But when this 4 and 3 are added, when this 4 and 3 are added, okay, okay, they may give you any value. They may give you any value starting from, you know, 1 and, you know, less than 7. Okay, so how it happens, I'll tell you everything. But like, try to understand what I'm trying to tell you here. So see, whenever you are adding, the basic difference between a scalar and the vector is here. That's whenever you are adding two scalar quantities, you are only getting the one answer. Only getting one answer. But sir, when you are adding two vectors, you may get any answer between certain range. between certain range. Sir, how come, sir? Now, see, this vector A and this vector B. So, vector have some direction. So, if you write like this is A vector, let's suppose 4 meter per second, and let's suppose this is 3 vector. This is 3 meter per second. Now, in this case, both are in the same direction. So, you can say that when these two vectors are added here, you can write, sir, 7 meter per second. You can write 7 meter per second, and obviously the direction is this. Okay, we'll talk about direction later. Let's talk about the magnitude only for time being. Okay. Okay, so if A vector and B vector both are in the same direction, obviously we will be getting 7. Now, if suppose we are having this vector 4 meter per second and we are having the vector 3 meter per second over here, okay, so it is having the direction also now. So, sir, this will come out to B. So, here A plus B. Okay, so this is the difference. There is nothing like vector subtraction, I tell you. Vector subtraction is कुछ नहीं होता. Vectors are always added. Okay, like here A and B are also added with their direction. So when you are adding these two, so obviously, sir, we are getting 1 meter per second. Okay, because these two are in opposite direction. Common sense, right? Common sense. Okay, okay. So A and B is 1 meter per second. Now please understand this. 4, 3 added, it gives 7 also. 4, 3 added, giving 1 also. Now if 4 is this, so they can be in any direction. 4 is this, okay, and 3 is this, okay, okay. When they will be added, what you are going to get? What you are going to get? So we are going to get like this. Okay, so how we are going to get like this? I'll tell you. But in this case, their addition, which we are calling as the resultant. What is resultant, sir? When two vectors are added, you are getting the solution. Whatever solution you are seeing it as the resultant. This is one name that is given to it. It's just the result. Okay. Okay. So here when you solve it, sir, so we know that we are going to get 5 meter per second. How come? Like Pythagoras theorem and all. Now here again A and B, when they are added, you are getting 5 meter per second. 5 meter per second. Okay. And I tell you, if this 4 meter per second and 3 meter per second, if they would be like this. Okay. Let's suppose they are going to be like this. Okay. Okay. Then this is going to be the resultant to it. Right. So again from here you are going to get something other than this value, these values that you have got till so far. So my point is, my dear, two scalar quantities, when they are added, you always get the same result. Okay, like 4 and 3, when they are added, you are going to always get 7. But when two vector quantities are added, you can get anything. You can get anything, but within some range. Like in this case, it will be 1 and it will be 7. So you might be reckoning that 1 is the difference between two vectors and 7 is the addition between two vectors. Are you getting my point? So I'll come to this. So, but the point is, see what kind of addition is this? So every time you are getting the different result. Every time, guys, you are getting the different result if you try to understand what I'm trying to say. Okay. So one very important point here that I come to get is that, sir, addition of vector addition of vector depends upon angle between the vector. Okay, the addition of vector depends upon the angle between the vectors. Okay, so if the angle between the vector changes, they will be having their result as change. So for example, we have seen distance and displacement, right? So distance is a scalar quantity. Let's suppose someone moved 4 meter east and then 3 meter north. Okay, so what is going to be the distance? So distance is a scalar quantity. You always add them. But what is going to be the displacement? So it is not going to be 5, but 7, but it will be going to be 5. We have solved this kind of questions. Huh? Displacement is the shortest distance between initial and final position. So we are going to get 5. Okay, so displacement will be 5, right? Okay, so you have when two vectors, 4 vector, 3 vector, when they are added, you are getting here the summation as 5. Now, similarly, 4, you move 4 here, and afterwards you move 3 in this direction. Still, your distance is going to be 7. You move 4 meter this way, and then you come back 3 meter this way. Still, your distance is going to be this. But in each of the cases, displacement will be different. So, my dear students, what happens? My dear students, what happens? So what happens that the displacement changes? Displacement changes when the orientation or direction of this vector are rearranged, or in another way, the angle between the vectors changes. So basically, vector addition clearly depends upon the angle between the vectors. So I hope it is fine to everyone. Okay. Now one more important thing, as I said, okay, one important point is this. Another important point here, I may mention it. So see, any physical quantity, any physical quantity, any physical quantity that may have direction, that may have direction, may not be a vector, may not be a vector. So what I'm trying to point out here, my dear students, so I'm trying to point it out here that so it is not necessary that any physical quantity is having some direction will be called upon as a vector. Okay, so any physical quantity having direction may necessarily not the vector. Okay, okay, but any vector, if any physical quantity is a vector, it necessarily have a direction. Are you getting my point? So what are the examples to it? There are many examples. So for example, if you say pressure, pressure has some direction or not? So definitely, sir, it has some direction. How come, sir? How come, sir? So, sir, it can be internal pressure, external pressure. So, for example, any container you are having, okay, you are having water or any fluid inside that container. So that fluid will exert pressure from inside to outside, like this, outwards. Okay, internal pressure. Now, if you have a body, you immerse it in some, liquid or fluid or anything. Okay, we are also subjected to some pressure from the air, right? Atmospheric pressure, we call it. Okay, kinetic theory of gases. The molecules of air are in random motion. When they are in random motion, they collide with each other and anything that comes their way, right? Okay, so whenever there is some mass and whenever there is change its velocity, moment happen to be. Now, whenever there is change in momentum, always there will be some force acting upon from the Newton-Baba law. Yes or no? And when force is acting upon and taken per unit area, it is known as the pressure. Okay, so pressure has some direction, but it is not a vector, it is a scalar quantity. Talking about fluid, we know there is a law, Pascal law, which states that at a point the pressure is independent of direction. So something independent of direction, that means it is not a vector quantity. Okay, so though it has direction, but this is not a vector, it is a scalar quantity. For example, stress. Okay, stress force per unit area. Stress do have some direction, but this is not a vector. It is actually tensor quantity. Okay, it is actually tensor quantity. So what is tensor quantity? So it is, you don't have to know it, but see, it is, a little if you improve upon the vector. Okay, normally they are represented in the form of matrices, and it depends upon the orientation of plane. Okay, okay, so just know this name, that stress is tensor. Electric current, the current have some direction, but this is not a, vector. How come, sir? Because see, let's suppose there is 8 ampere current coming from here, 5 ampere current coming from here, so the resultant will be 8 plus 5, 13. Are you getting my point? If 5 is coming not from here but from here also, the resultant will be 13 ampere only. So what I'm trying to say is here that, sir, not always it is required that something is enjoying to have some direction is a vector quantity. It may not be a vector. Understood? Okay, I hope it is clear to everyone. So vectors are those which are having magnitude, they are having that direction, as well as they are having to obey, they have to obey the vector law of addition. I hope it is clear to everyone. Now moving ahead. Now moving ahead. So now how we do represent the vector. See, each and everything is very, very important. So we already know it. So just listen to me once. Okay. I'll be fast enough here. Okay. See, we know all these things, but they have to be in your mind because see, when we will be moving towards the addition part, you will see a lot of silly mistake happen from the you. Right. So each and everything that I'm telling you is important. Just go through it once. So sir, we know what is a vector. So the vector is represented like this, okay? Is represented like this, like an arrow, okay? And this is something we know. So this is the tail of it, and this is the head of the vector. So any vector can be represented by the help of an arrow having the tail and having the head, okay? Okay. So basically, this arrow. So everyone know what this arrow means, no? So basically the direction, so like this kind of a symbol we see all around us. No, we go outside, we'll see, okay, this shop is in this way. This shop is in this way. You are moving over the highway, you will be having the signboards. Okay. Okay, so you know this arrow, right? But now this is the tail and this is the head. So from tail to head, it gives the direction. It gives the direction. And the length to this, please understand this. The length of this arrow. So this arrow would have some length, no? Okay. Okay, so this length of the arrow gives the magnitude of the vector. Okay. So, sir, how this is relevant? How this is relevant? So, let me say that there is a body on which the force is there, that is 10 Newton, acting towards east. Acting towards east. Okay. Now, how you are going to represent this vector on some body? So, how we can represent, sir? How we can represent, sir? So, towards the east. Towards the east, that means that we know very well east, west, okay, north, south, okay. Now this is the east, okay, so it is acting towards the east, that means the head of it is pointing towards the east, and this is 10 Newton. So we know that the length of this vector is 10 Newton. It must be 10 Newton. Now, sir, if we want to represent it in the copy, or if we want to represent this thing graphically, if we want to represent this thing graphically, sir, how I could represent this? How could I give it? So, sir, the meter scale that we are having, the normal scale we are having, so in that we are having into centimeter. Okay. Okay. So, sir, there is no scale is coming which gives you 10 Newton in measurement. So what we do, we consider a scale. We have to consider a suitable scale. So what is the meaning of it? So for example, you are assuming that in your scale, the 1 centimeter is equivalent to 1 Newton. So if you want to show this in your notebook, or if you want to show it in your copy, the right way is that you pick up a scale, you draw by seeing the 10 centimeter from. So do we have to do all this? No, no, no. Just I'm telling you to. So all this information you are going to use later on. Okay, very important information. We ignore it. We do not give sufficient time to this, and that is the very reason that we make silly mistakes. A lot of students tells me, that's why in physics what happens. So we make a lot of silly mistakes. We knew most of the thing, but we end up making the silly mistake. So what is the reason? What is the root cause of it, that we are not good, or we do not give sufficient time or sufficient attention towards the details? Okay. Okay. So in the topics like this, like vector, so it is applicable at so many places, right? The next chapter, Newton law of motion, talks mostly about the forces. So we need to do that pulley problem, the spring problem, friction. All these are the vectors. So we are dealing with the velocity, acceleration. All these are the vectors. Now, if you want to be good at those, so you must be having good understanding of vectors. So that is why we are here. So now what you did, sir, you made a line of 10 centimeter over the scale, and in this direction, because it says that it is given, it is acting towards the east. So you may write 10 centimeter here. So you have drawn the line, and 1 centimeter is equal to 10 centimeter. That means that the length is 10 Newton. Okay. Okay, so this is one way of representing. This is one way of representing So it is normally given like this, okay, because not always you will pick up a scale or something. You will, if you are making this like this arrow, so that means that this is the direction of this vector, that is the force, and this length gives you the magnitude of this force. I hope it is clear to everyone. So this is one way of representing. This is called as the graphical way. Now the other way could be, so you represent, this is the standard way of representing a vector, f और उसके ऊपर ये arrow, right? F and the arrow on the head of the F, okay? And this is 10 Newton. Now from here you'll have to give the, what you'll have to tell the direction. So 10 Newton towards the east, right? So this arrow points towards the east. So if I say that we have some force that is equal to 5 Newton west, still you will be using this arrow only. This arrow only. So this arrow doesn't give you that the force is in this direction. This is just the standard way of presenting, the vector. So when you put this arrow on some quantity, some physical quantity over some physical quantity, so basically you are trying to tell that this quantity is a vector quantity, or it may be in any direction, not necessarily it is in each direction. Understood? Don't get confused that way. Okay, so this is how we represent the vector. Now again, vector, any vector consists of two things. One is magnitude, other is direction. One is magnitude, other is direction. Okay, okay. So here we can see, when we see like this, we can see the magnitude of it and we can see the direction of it. Understood? Okay, okay. So see, now when we are talking about the magnitude, so see, if we talk about the magnitude, so what is the magnitude? So clearly 5 Newton is the magnitude. So this is given like this, right? So you are putting these two walls over the physical quantity or the vector. It just, the meaning of it is that you are now talking about the magnitude of this vector. So this, when you are putting the walls here, when you are putting the sign of mod here, you can write it as 5 Newton. And sometimes if only F is also written, this is also refers to the magnitude. Okay, this is something somewhat, it is given like this also, at times it is given like this also. Now any of this way if given, this is nothing but the magnitude of it. This is nothing but the magnitude of it. Sir, where we are going to use it? Sir, there is a lot of use to it. Please bear with me. Okay, you will come to know. Okay, when we'll be solving the problems. Okay, now let's say, sir, so direction is one important, aspect of a vector. Agree? Yes, sir, certainly we agree to it. Direction is one of the very, very important factor to understand a vector. So let's talk about the direction a bit. So, sir, what is the direction? What is the direction? So, general, if we talk about the direction, so this is going to be the direction, right? Okay. So, in general, we know this is the east, this is the west, this is the east, this is the west, this is north, this is south. So basically, if some vector is there, is pointing towards the east, so that means it is in this direction. If it points towards the north, it will be in this direction. If it points towards the west, it is going to be in this direction. And if it is pointing towards the south, it is going to be represented like this. Okay, represented like this. I hope it is fine to everyone. Okay, okay. Now please understand this, guys. What we must understand. Now please understand this. So if I ask you that what is the northeast direction, so the northeast direction is going to be exactly from the middle of it. Okay, okay. So this is your northeast direction, obviously. So whenever it is said that some vector is in northeast direction, so you can now think of that what is the direction of that particular vector. And when you are talking about the northeast, so it means that it is exactly 45 degree. Exactly 45 degree. Understood? Now, similarly, if you are asked to interpret, or if you are asked or given that some vector is there in northwest direction, so in northwest direction, that means the vector is between the north direction and west direction, exactly between. So exactly between the north and the west direction, it means this is going to be 45 degree and this is also going to be 45 degree. Now similarly we have here, so this is west and south direction, so it will become 45 degree. This is also going to become 45 degree. So west south direction, okay, obviously. Now this is southeast direction, so it is west south southwest, both are the same thing. Now this is going to be southeast direction, isn't it? Okay, again it will be 45 degree. Okay, so when you are asked to imagine or asked to think of a vector in any of this direction, it can be east, north, or northeast, west, north, northwest. Okay, so this is very simple. This is very simple. Absolutely simple. No problem at all. Now, if I say, guys, that some vector is 30 degree north of east, so 30 degree north of east, okay? Or if I say that some vector is, let's suppose, 15 degree east of north, 15 degree east of north, right? East of north. Now, how you are going to show these vectors, how you are going to think of their direction, okay, their direction. Now, that is the question. That is the question. So, north, east, south, west, these are we are okay with. If northeast, then we are okay with. Okay, exactly. If it is written northeast, no angle is mentioned, so that means that it is exactly in between. This thing we got. Now, if we are given or if we are asked to about these direction, if we are asked to do about these direction, then what we have to do? Then what we are supposed to do? Then we what we are supposed to do? So, sir, in this case, now in this case, what is going to be the case? So, sir, it is east, west, north, and south. Okay, east, west, north, and south. Okay, so it is east, west, north, and south. So 30 degree north of east. 30 degree north of east. So how you are going to show it here? How will be you be thinking of it? Now please understand this 30 degree north of east. That is, you are measuring this angle towards the north from the east. Okay, when it is written north of east, that means you are considering this angle towards the north from the east, right? From the east. When it is written 15 degree east of north, when it is written 15 degree east of north, so when it is written 15 degree east of north, that means that you are considering the vector in the direction taken 15 degree from the north towards the east. From the north towards the east. I hope it is clear to everyone. Now, if you want to represent, so this is 30 degree north of east, this is 15 degree east of north. Okay, somewhat it is written like this, east of north, right? EN, east of north. It is 30 degree north of east. Okay, okay. Now, similarly, if we want to present 20 degree, let's suppose we want to give you 20 degree, 20 degree north of west, north of west. Okay, 20 degree, if we are asked about 20 degree north of west, or we say we want to represent 37 degree east of south, right? Or we want to represent, let's suppose, 53 degree south, or I may write, okay, south of west. Now, how you will be representing these in this, orientation? Can you please try to do it? Please represent all these. Please represent all these. So it is going to be north of 20 degree north of west. Okay, so that means you measure from the west 20 degree towards the north. Okay, 20 degree towards the north. So this is going to be like this vector. Now it says 37 degree east of south. 37 degree east of south. That means that you are measuring from the south towards the east. So this could be 37 degree east of south. This could be 37 degree east of south. Now it says 53 degrees. So these things are very, very important. 53 degree. So this is going to be this. Now 50 degrees south of west. Okay, so you measured from the west towards 50 degree, 53 degree in the south direction. So from west, okay, south of west, okay. So 50 degree, 53 degree towards the south from the west. I hope this is clear to everyone, right? Okay, right. Now, if you want to represent, let's suppose, let me give you some problem. So let's suppose we are having 2 meter per second and we want to represent it 53 degree west of south. So why are you giving so much time to this? My dear, please understand this. This is the points where I have seen students are making mistakes. So they know many, many things, that they know the formula, they know graphical method, analytical method, this law, that law. Okay, but what happens? They make mistake in making the vector correctly. Okay, and then the game is over, right? So 2 meter per second, 53 degree west of south. Just try to do that. Let's try to do that. Now 2 meter per second, 53 degree west of north. 53 degree west of north. So, sir, very, very simple, sir. So we understand that this is east, this is west, this is north, this is south. Okay, and 53 degree west of north. So that means you have taken this angle, you have taken this angle. No problem, she said. We have started with the vector as promised. Okay, we have started the vector as promised, and we just have now, till now we have seen some basic things about vector, that we know that vector depends upon the magnitude, direction, and how we are representing the vector. We are just talking about it, so nothing is missed, right? Don't worry, these things we already know. Just I am giving some time to it so that you understand this well, so that we can use it further. Okay, okay. Now let's come to the next point. So see, from here I'll be assuming that you will be able to represent the vector completely and correctly. You will be able to see the direction of it. So sign, see what is happening, like 2 meter per second is a vector, 53 degree west of north. So how we understand this is not a speed but velocity? Because in vector, because if magnitude and direction both are there, so definitely it is a vector, right? Because vector is something which is having direction, magnitude, and which obeys the laws of vector addition. So this 2 meter per second, 53 degree. No, no, no problem, Shita. No problem. Not at all. Okay. Just try to focus from this point onwards. So these things in vector, we know something about it now. But now I am going to give it some good direction. We'll be solving some good questions, and I'm trying to complete so as much as possible in the vector today itself. Okay, I don't want to stretch it. So we'll be doing a long session today. Okay, so that we come to some good understanding of vector. Okay, so when we say 2 meter per second, 53 degree west of north. So see, simple, what is it? West of north. So you are representing this vector, you are considering this vector, you have taken the angle 53 degree and west of north. That means you are measuring from the north towards the west. Okay, like here I have represented, if it is 30 degree north of east, 30 degree north of east, that means that you have measured from the east 30 degree towards the north. Okay, very, very simple. And this already the east, west, north, south. And if it is written that some vector is in northeast direction, so it is exactly in the middle of north direction and east direction, that is at 45 degree. I hope you can understand till now. Wonderful. Now please understand this. Okay, so there are few important factors. So see, we are talking from zero level from the vector. So if someone is not knowing vector at all, I am considering if someone is watching the video who never have heard about the vector even, will also be able to understand. Okay, very soon we'll be starting with the laws of addition and everything. Okay, we'll try to complete as much as possible today itself. So now please understand there are few very important things about the vector that we must be, very much prompt to do. Okay, so if vector is rotated by, if vector is rotated by, if vector is rotated by 2 pi, what do you mean by 2 pi? So 2 pi is 360 degree. So if vector is rotated by 2 pi, it remain the same. It remain the same. Are you getting my point? Okay, do you agree? So if there is a vector, so quite obvious it is, if there is a vector pointing towards here, and if we rotate it by 360 degree, it will again come back to its original position, original state. So it will remain the same, right? Now, one very important thing is that vectors, so in vectors, parallel shift is allowed. This is highly, highly useful and we will be using it a lot. So in vectors, my dear, the parallel shift is allowed. Parallel shift is allowed. So what is the meaning of this parallel shift? So suppose that we are having some vector here. Okay. Now I can draw this vector anywhere on this screen, anywhere on this screen, but without changing its magnitude and direction. So what is the magnitude of a vector? So it is given by the length of this arrow. And what is the direction? So the point of the head, okay, this arrow, head and tail we are having. This is the tail, this is the head. So I can draw this vector anywhere. I can draw this vector anywhere on this screen, but I need to be careful that I am not changing the magnitude or direction of this vector. Direction of this vector. So how we'll be using it? So this will be used in each and every law of vector. Are you getting my point? Even in resolution also. So let's suppose we are having a vector A here. Okay, so this is the magnitude of this vector and this is the direction of this vector, and some vector is B here. Some vector is B here. Okay. Okay. Now you want to bring them closer. You want to do some vector addition that we'll be talking about later. So these two vectors are there, and now you can want to bring them nearby. So you can do parallel shifting of them. So you can bring this B, you can make this B here. Okay. What you have done, sir? You have done the parallel shift. You want to take this A to near B, so you can make A from like this. Okay. So you can always do the parallel shifting of vector. Any vector quantity can be parallel shifted provided its magnitude and direction doesn't change, right? Okay. What is the meaning? So for example, let's suppose some vector is making 30-degree angle from the horizontal. Let's suppose it is 5 meter per second. Okay. Let's suppose it is 5 meter per second. So see, you take this 5 meter per second wherever you want, keeping in mind that you cannot change this angle of 30 degree and you cannot change the magnitude of this 5 meter per second. Understood? Understood? I hope it is fine to everyone. Right? Very, very simple. Very, very simple. Now, the third and the most important point is, very, very important. So the angle between two vectors, okay, don't you ever forget this. In today's class, not here, but on Unacademy Special, okay, so we do classes on the app also. No? So on Unacademy Special class, many students make mistake in this point today, okay, when I was doing one question, right? So you have to keep this in your mind. So the angle between two vectors is the smaller angle. is the smaller angle between these two vectors, a smaller angle the vectors, between the vectors when they are joined. When they are joined. Tail to tail. Okay, so whenever you are seeking the angle between two vectors, so sir, in the starting I told you, sir, vectors. So vectors are something which which observes or which obeys the vector law of addition. Okay, then I have quoted, so the addition of two vectors or the resultant of two vectors depends upon the angle between two vectors. So now you can understand what is the importance of angle in vectors. Okay, so angle between two vectors is the smaller angle. Is the smaller angle when two vectors are joined tail to tail. Two vectors are joined tail to tail. So for example, let's suppose we are having a vector A. Okay, we are having a vector A, so you can represent it like this, or you can just write like this also, because this arrow gives the direction of this vector A, and you know the length gives the magnitude. So this is the vector A. Now let's suppose we have one more vector B like this. We have one more vector B like this, which is making the angle from the horizontal as 120 degree. Okay. Okay, now you want to you are asked about, or you want to know the angle between these two vectors A and B. So what you can do? So you can do the parallel shifting. So either you can take A to B, doesn't matter, there's no problem, or you can take B to A. Okay, so parallel shifting are always allowed. So if I bring this B near A and join it, so I could join it here also, but I'm not joining it here. Why so, sir? Because I want to find the angle between them. So they must be joined tail to tail. They must be joined tail to tail. So when they are joined tail to tail, what is going to be the angle between them, sir? Obviously, it is 120. Obviously, it is 120. Or sir, the angle between these two is also 240, right? Also 240, right? Isn't it? The angle between these are also 240. So, sir, what is the angle between two vectors? So, it is the smaller angle between the vectors. So, what is the angle between this A and B? You can say so. The angle between vector A and the vector B is going to be 120. Do you agree to it? Yes or no? Do you understand it? Okay. Now, this way, can I tell you one big thing? So, what is that big thing? Sir, angle between any two vectors. So let's suppose the angle between the vectors, we are calling it theta, and we'll keep calling it theta. We'll keep calling it theta. So angle between the vectors is always greater than or equal to 0 and less than equal to 180. Can the angle between any two vectors be greater than 180? Is it possible? Is it possible? Because if it is greater than 180, you will take the difference of it from 360. Okay? Yes or no? Please answer me. Do you agree to it or not? Please answer me. Very, very important. Very, very important. Very, very important. Right? Okay? No worries, sir. No worries. Now, if I say that what is the angle between this is a vector A and this is a vector B, and let's suppose this is 60 degree from the horizontal. So what is going to be the angle between A and B? So you can say, sir, we'll be doing the parallel shift. Sir, we'll bring this B near A and join both of them tail to tail, and then we'll check the angle between them. So it is 60 degrees. So the theta is 60 because the other one is 300. So basically the angle between two vectors is the smaller of the two angles. Okay, so it is going to be 60 degree. Now, if I say that we are having a vector A like this and we are having a vector B like this, we are having a vector B like this, and this is the angle 120. So, what is going to be the angle between A and B here? In this case, can you tell me? Can you tell me that? So what is going to be the angle between them? So now many students make mistakes. So see, they say that this angle between these two vectors, clearly it is 120. It is not 120, my dear. It is not 120 because see, the angle between the vectors can be seen when they are joined tail to tail. They are joined tail to tail. So right now they are not joined tail to tail. Yes, yes, Shweta. So when they are not joined tail to tail, what you have to do? You have to do the parallel shift. So if you shift the parallel shift this B from here to here, what is going to be this angle? So this is going to be 60 degree because this is 120. So this is going to be 60. So again, theta is going to be 60 degrees. So guys, make no mistake. Make no mistake. The angle between two vectors is taken when they are joined tail to tail. Wonderful. Wonderful. Now let's say, let me make something. Raichun. Wonderful, beta. The answer is 60 degree. Very well. So Raichun, we are Raichun. Am I pronouncing your name properly? Yeah. So what we are doing, we are trying to understand the basics of vectors because we are dealing in kinematics. Okay. Okay, हम kinematics में बात कर रहे हैं. So we are dealing in kinematics. Motion in a straight line we have done till some extent, and on this channel we already have completed units and measurement in physics. Okay. Okay. So 60 degree, and this is, let's suppose, let me make one more vector. Uh, yeah, yeah, I could reckon that. So can you correct me in that case so that I can pronounce it properly? Yeah. Okay. So this is vector C. Okay, this is vector C. Now you need to give me the angle between A and B. Okay, what is theta between angle between? So there also see. So this is not necessary that always retune, retune. Yeah, wonderful. Angle between A and B. Let's say between A and C and between B and C. Can you give me the angle between these factors? Rechun and Shrisai. Yeah, please go for it. Please go for it. Hmm. Please do it. So, Rechun, I give you some brief what we are doing on the channel. So here we are trying to finish your physics by the end of the March. Now for that we have started doing it. We have started the YouTube channel very early. Very not much time has gone. So we have yet completed units and measurement. Biology is also running on this channel. Okay, and we are also dealing with the physics part. So kinematics we started. We are doing motion in a straight line and motion in a plane together. So we have reached motion in a straight line to some extent, and now today we have started with motion in a plane also. Because if you see your books, textbook, all this is given in your fourth chapter, na? Motion in a plane. Now right away with this vector, I am planning to start with NLM also. Are you getting my point? Okay. So your fifth chapter will also be started. Okay. And from NLM, I may move to the stress part, that is the properties of material, quite related. Okay, we'll see, we'll see. Okay, okay. So please get me the angle, sir. Yeah, Sri Sai seems correct. Wonderful. No problem, no problem. Yeah, please go for it. You also answer. Sri Sai, what about B and C, my dear? Hi, Manthan. We are dealing in vectors. आज के सेशन में हम वेक्टर्स की बात कर रहे हैं. We are talking in vectors. So basically, we have completed motion in a straight line to some extent, and we have now started with the motion in a plane also. And after understanding something about vector, we'll take them together. Okay, okay. Now please understand this. So see the important point is that whenever you are finding the angle between two vectors, you need to join them tail to tail. ठीक है? टेल से टेल मिलानी है. एक गाना था ना हिंदी में, ताल से ताल मिला, वैसे टेल से टेल मिला. ठीक है? टेल टू टेल यू हैव टू ज्वाइन. मतलब differentiation and integration we already have done, my dear. Okay? Differentiation and integration we already have done. Okay? You'll get to see that in the part of kinematics. Okay? So some differentiation is required to do for the kinematics, some sort of concept, some integration is required, so that we already have completed. Okay? Now please understand, let me do it. So see, you always have to join. Yeah, this is she said for this reason because her service went out for 3 4 days to some place. So basically, he'll be back from 26. He'll be keep posting his videos. Okay, but he cannot be live till 26. That is the reason. But don't worry, I'm here now. I'll be taking 2 3 hours. Don't worry. Every day till he is back. Till he is back 4 days. It's a matter of 4 days. So you understand that teachers are also having some social implications, right? So we also have something urgent came up. So he's gone for 4 days. He'll be resuming from 26. Okay. So he'll be live with you from 26. Okay. So that is why that 75 hard challenge thing is starting for biology from 26. Right? And 23rd from 23rd every day will do at least half hour, 40 minutes of question in a zippy, right? In quickly. Okay. Okay. So now let's move to the point. So now, so we whenever we are seeing the angle between two vectors, we have to join tail to tail. Now please understand. You see, in the examination we don't have this much time that sir we make it here, then there. So you do everything here. Now if this is 60 and if I extend this line, so this also has to be 60 vertically opposite. Now please think. So how we are extending it, sir? Yeah, three sides. Don't worry, we'll be extending from now. Okay, so this is 60 degrees. So this is going to be like this. Now, when this is going to be like this, my dear, this is 60, this is also 60. So this is also 30 degrees. This is also 30 degrees. So now we are making the vector B by parallel shift here. Now you can see that when we parallel shift this vector B, A and B are joined tail to tail. So this is going to be 60 degrees. Yes or no? Ritual, would you care to answer, my dear? Are you understanding it? Now, similarly, sir, angle between A and C. So A and C are already joined tail to tail. So when they are already joined tail to tail, the angle between them is gonna be, sir, this is 30, this is 45. So this is all obviously 45. So this is 45 plus 30. So if I see the angle till here, so this is 45. So this is going to be 75. Okay, now what is going to be the angle between B and C? So if B is here, now see, check, B and C are joined tail to tail already. B and C are joined tail to tail already. So when B and C are joined tail to tail already, the angle between them is, so this is 30, this is 45, the whole is 90, so this is going to be 15 degrees. So one very important point, again I am emphasizing on it, that whenever you are joining two vectors, whenever you are seeking the angle between two vectors, you always have to join them from tail to tail. Understood? Understood? Okay, right? So there are some new students. So let me give you. So this is me, है ना? थोड़ा सा आप किससे पढ़ रहे हो, you must know. So this is a brief introduction about me. Okay, I have completed PhD MTech from IIT Roorkee. These all are the credentials. So let's get back to the point. Don't waste the time. Now, ah. So now let's talk about something. So let's move further. Okay. So basically, let's understand types of vector also. Types of vectors. So is it important? Sir, these important information will help you giving the correct solution in bigger question. Are you getting my point? Now please understand this. So what are different types of vectors? So we'll keep it quick. So there is equal vector. So if two vectors are equal, so they must be having what? Same magnitude. Okay, a vector is given by magnitude and direction, same direction. So if two vectors are equal, they must have same magnitude and they must have same direction. Okay, also they must have same unit, isn't it? Isn't it? You are not going to add velocity to the force, no? Okay, so this already we know from the dimension chapter we have seen. Okay, so if these three conditions are there, you can say the vector is equal. So for example, let's suppose this is a force of 5 Newton and this is a force of 5 Newton. So they both are equal vectors. They both are equal vectors. Remember, so what is important point here? The important point is just merely having the same magnitude doesn't make two vectors equal. Okay, they have to have the same direction as well. They have to have the same direction as well. Okay, okay, are you getting my point? Okay, we'll use this now. Let's take it quickly. Now, very important. Okay, okay, Rishu. No worries, no worries, no worries. Thanks for coming. You can see the recordings if you want to, and you can come live. Normally, the physics classes are at 3 p.m. and biology classes you can see the time of that also. Have a good day, my dear. So, negative of a vector. What do we mean by negative of a vector? Very important concept. See, this is going to be of high use. Negative of a vector. Now, please understand this. So, when you say negative of a vector, okay. So basically, if there is a vector, let's suppose 5 Newton. So what is going? Let's call it A. So this is vector A. This is vector A. Okay. Now this vector A is 5 Newton. So if you want to make negative of the vector, so negative of A is going to be vector having the same magnitude but opposite direction. Are you getting my point? Just you have to reverse the direction. So what is the relevance of it? What is the relevance of it? So for example, I say that you have cricket World Cup is going on now. So there is a ball and there is a batsman. Okay. Now this batsman have hit the ball through his bat. So this ball strikes here, and then he has hit it in this direction. He has hit it in this direction. So it may have come with some velocity and it goes in some velocity. Are you getting my point? It goes out with some velocity. Now, if you want to find the change in the velocity, what is going to be the change in velocity? So, sir, you will say, sir, it is going to be the it is going to be the V1 minus V2. So I'm just trying to tell you the relevance of it. Later on, when we'll go to the addition, we'll do it very, very deeply. We'll just try to just make some, base for that. So when there is a ball is coming, someone hit it. Okay, so it came to some velocity, it goes to some velocity. So you started the collision or what? Don't worry, just talking in a very simple note of velocity, just trying to tell you what is the relevance of a negative of vector. So in physics, multiple times in multiple chapters, we are supposed to find the difference of vectors, like here in this case, right? Okay. Now please understand this. There is nothing like vector subtraction. So sir, you may say, so these two vectors are getting subtracted. Or they are not getting subtracted. Please try to understand this. They are not getting subtracted. Sir, how come? It is clearly they are getting subtracted. No, sir. Again, they are not getting subtracted. So what is happening to them? So they are actually getting added. How they are getting added, sir? They are getting added this way. They are getting added this way. There is nothing like vector subtraction, mind you. Okay, so what we can write this? We can write vector v1 plus negative of vector v2. Negative of vector v2. Now please understand this. So we are having this vector v1 and this is the direction of v2. This is the direction of v2. So you are not going to find the resultant of them. You are not going to find their resultant, but you need to find the resultant of negative of v2. So negative of v2 means that this v2 is now reverse in direction, but it is having the same magnitude. So basically you are interested in summing these two vectors. Are you getting my point? You are interested in summing these two vectors, not these two vectors, not the green ones. Are you getting my point? Are you getting my point? So negative of a vector is of high use. Okay, it's of high use. We'll be coming to that very soon. Is that clear? But till you got, what do we mean by the negative of vector? So when you reverse the direction of some vector without changing its magnitude, okay, you call it the negative of the vector. I hope it is clear to everyone. Yeah, Shishai and any other student who is live here. Hmm? Okay, okay. Now, one important takeaway point from here may be that if there is a vector A, let's suppose there is a vector A, okay, okay, and there is a vector minus A. So this is negative of vector A. So are they both equal? If I ask you, understand this. So it is not, see, see, do you agree, Shizai, that the velocity is a vector quantity? Okay, do you agree to it? Now, when I say that the velocity, find the change in velocity, so you are interested in finding the difference of velocities. Do you agree? Okay. So now initial velocity, that is v1 vector. Okay. So you may say that change in velocity must be v2 minus v1. I just trying to give you the relevance of you know this thing. So if you want to do it like this, so v2 minus v1 you can write. Okay, or let's do it again, don't worry, I'll just tell you. Okay, v2 minus v1 if you are thinking of, so because I'm not getting into taking you to into the subsection, I'm just trying to tell you that what is the how we do the subtraction here. So please understand this again. So let's suppose we are having a vector v1 in this direction and now the ball is hit by this vector and it goes like this. It is vector v2. It is vector v2. So if you want to be correct at this point, so we can write v2 minus v1. This is the change of velocity. Do you agree? Yes, sir, we do agree to it. Now please understand this. Please understand this. So now when we are writing this negative sign, so change is always the difference, right? So you want to make the difference of the final velocity and the initial velocity. Both are the vectors. So people think in this way that two vectors are getting subtracted. But it is not true. Why it is not true? Because obviously if you use some basic algebra, you can write like this also, na? Plus minus of v1 plus minus of v1, because all the laws state that they are law of vector addition, isn't it? Okay, so basically what does it mean? what I was previously meaning, v1 minus v2 when I have written. Okay. Okay, so I was just trying to tell you the difference. Okay, so how? So we can write that v2 plus minus v1. So it is basically, we can say it is the addition of v2 vector and negative of v1 vector. So it is again vector addition only. And if you want to see it graphically at this point of time, you can write, so sir, this is v1, this is v1. So we are not interested in finding the adding these two vectors. We are not interested. We are interested in adding these two. Which one? If I write this v1 like this, that is also fine. Na? Negative of this vector. So we are interested in finding the resultant of these two actually. Understood? Understood? Okay, so negative of a vector is highly relevant, and basically negative of a vector is something which is having the same magnitude but opposite direction. Any vector negative means that you have opposite direction but having the same magnitude. Okay, so I was saying, let's suppose there is a vector, let's say 5 Newton east, vector A, so it represents the force. So what is going to be the negative of this vector? So magnitude will remain same and west, it will be west. Now I have a question for you. If I say, please listen to me carefully, vector A is equal to negative of vector A. Please listen to me. If I say this statement that vector A is equal to negative of vector A, would you say yes or no? Vector A is equal to negative of vector A. You say right or wrong? Are they both equal? Are they both equal? Are they equal vectors? So does it have any relevance? Trust me. Trust me, it is having a lot of relevance. You are going to see it. So no, sir, they are not. They are not the same vector, because vector is something which is having magnitude, which is having direction. Okay, okay. So This is not equal vectors. Vector A is not equal to negative of vector A because they both are having the same magnitude, but they are not having the same direction. Wonderful. So now can we write like this? But their magnitude is same. Okay, magnitude is same. So can we write like this? Okay. But the minus goes in the mod, it will become positive, so they will be both equal. I don't talk like that now. This minus a itself represents a vector. Are you yes or no? Okay, is it fine? Is it fine? Okay. I hope it is clear to everyone. Right? Okay. So So, negative vector is clear. Now we'll be using it a lot and then we'll be seeing it. Now, what is parallel and anti-parallel? So, as the name suggests, parallel and anti-parallel. So, the vector which are having the parallel direction, they will be parallel. So, for example, we are having a vector A and we are having a vector B. We are having a vector B. So this is what? This is parallel. This is parallel vector. So when two vectors are parallel to each other, what is going to be the angle between them? So sir, tail to tail, join them tail to tail. So when you are joining them tail to tail, you are bringing A here or you are taking B there. The angle between these two is going to become 0. So when the vectors are parallel, their angle is 0. So they have to be equal in magnitude also, not necessarily. Okay. And I have made the arrows significantly different from each other. So obviously this arrow length gives the magnitude of the vector. So how come the magnitude be same? So they are not same. Now talking about the anti-parallel. So if this is A and this is B, okay, they may be like this. So what do we mean by this? Okay. Okay, so B here, A and B here are known as anti-parallel vector. So, sir, clearly they are having angle of. So, if I ask you what is the angle of between A and B in this case, what would be the angle between them? What would be the angle between them? Please answer me. So obviously, sir, it will be 180 degrees. So when we are joining this A and B tail to tail, the angle between them is going to be 180 exactly. 180 exactly. Right. Now, so what is collinear and coplanar vector? What is collinear and coplanar vector? Good afternoon, Thai. Very, very good afternoon to you. Welcome to the session, beta. We are talking about the vectors. अभी तक basic ही चल रहा है. Till now we have talking about the basic of vector. You have joined at the right time. We are about to start the addition of the vector, which is very, very important. Okay. Now, collinear and coplanar vector. So what do we mean by collinear? So if two vectors are having the same line, they are on the same line or the same axis, they are known as the collinear vector. So let's suppose this is vector A and this is vector B. This is vector B. And let's suppose this is vector C. So they all are at the same line. They are acting on the same line. So they are going to call upon as the collinear vector. Is it clear? Very, very simple. Sir. Very, very simple. Okay. Okay. They may be, yeah. Yeah, yeah, yeah. She said, wonderful. Now, what is the coplanar vector? So now please understand this. What is the coplanar vector? See, what is the coplanar vector? So the coplanar vector is going to be, so basically the vectors which are lying in the same plane. Vectors obviously in the vectors in the same plane. So if there are some number of vectors and they are having to be in the same plane, we call it coplanar vector. Now, I want to tell you something here. So, what do you want to tell us? So, if there are two vectors only, if there are two vectors only, so remember, two vectors are always coplanar. Two vectors are always coplanar. Now, I have a question to you. So, do you understand what is a plane, right? Two dimension, 2D. So, for example, you are watching me on some screen. Your screen is two dimension. Hoping that nobody is seeing me in 3D. Okay. And even if you are watching me in 3D, you will be looking at me in 2D. So, screen is your two dimension. Board is your two dimension. The page on your copy is two dimension. Now, please understand this. If there are two vectors, you make any angle between them, you put them like any way, they will be in the same direction. So, for example, if you see two fingers of mine like this, okay, if you see two fingers of mine like this, so they are in the same plane. How come they are in the same plane? So, if you see, sir, they are in the same plane, please understand this. So, if you make two vectors like this is one vector, this is one vector, they are in the same plane only. If you make two vectors, so they are in the same plane only, they are in the plane of the screen. But what if we change the plane of these angles? Okay, what if we shift it? So please observe this. So I have something to you. So like these two vectors, so I can put it here. So are they in the same plane? So you can, so if you have a copy, so this is a plane, right? This is a plane. Okay. So when guys, this is a plane, my dear, so you can do it like this. So if two vectors are there, if they are like this, pointed towards me, so you can place them parallel to this plane, right? So you can keep two pens. So I am unfortunately I'm not having any pen here other than my digital pen. Otherwise, from the pen I could have shown you. So you place two pens, okay, and you keep them anyway. You can always arrange a plane parallel to it. So the point is, if there is only two actors, they are always and always coplanar. They are always and always coplanar. Okay. So it's like, for example, we have X, we have Y, we have Z. Okay. Now I hope you understand that X refers to this, Y refers to this, and Z refers to this. Okay. So if you are sitting in a room, okay, if you are sitting in a room, just try to look at the corner of the room. Any corner you see. Any corner, I am very sure that you would be seeing, observing three lines. One is going up, one is going here, one is going here. Three direction. Okay. So each of the wall of your room is a plane. Now you place two pens. You can always place two pens, no matter how you are placing them together. You can always have some plane that they are both lie same. So simple thing, two vectors are always lie in the same plane. But if there are three vectors, what happens if there are three vectors or more than two vectors? So when there are more than two vectors, okay, they can be more than two vectors, they can be coplanar, they can be coplanar or non-coplanar. Vector, does it need to be more than one? I didn't get that. There can be one vector only. One vector is there, so always there is there any confusion? So if there is one vector, it is always in a plane only, isn't it? So if there is only one vector, so it happens to be always coplanar, isn't it? You see, this is one vector. I can place like this pen pointing towards you. So you see there is a plane parallel to it. If I twist it like this, no, coplanar vector are those vectors which lie in the same plane, right? So if in a system, please understand this, if in a system there are two vectors, they both of the vectors are jointly called as coplanar vectors. Are you getting my point? If there are five vectors and five vectors lies in the same plane, they all together known as the coplanar vectors. Are you getting my point? If in that context you are asking, right? If there are three vectors, two are in the same plane, the third one is in the other plane. So in that system of problem, those two which are lying on the same plane will be coplanar vector. The third one which is in other plane will be non-coplanar vector. That is the meaning of it. Understood? Understood? Now please think. Okay, you got this. So now please think in this way. So if we have a vector here, if we have a vector like this, if we have a vector like this, see this middle finger like this, like this. So these three fingers representing three axes. So if these three vectors are there, are they in the same plane? No, sir, they are not in the same plane. But can they be in the same plane? Yes, sir, they can be in the same plane too. See all these fingers. So can we do like this? Two fingers like this. Okay, so if these two vectors, so they can be in different plane also, they can be in the same plane also. So see, simple funda. If there is two vectors somewhere in a problem, they always to be coplanar. But if there are two or more vectors, they can be coplanar, they cannot be no coplanar. Anything can happen. Is that clear, my dear? Very important. Two vectors are always coplanar. Understood? Understood? Yeah. Now, very importantly, very importantly, we have unit vector. We have unit vector. So this is going to be highly useful when we'll be coming to the Cartesian coordinate thing. Okay. And later on, this may be used in when we'll be talking in a streamline or something like that. So highly useful thing. Please understand this. So unit vector, what do we mean by unity? So unity means one. Okay, unit. Unit means unity. Unity means one. So basically, what is unit vector? So it is the vector. It is the vector. It is the vector which has a magnitude. Which has a magnitude of unity. Which has a magnitude of unity. Okay. Okay. So when it is having the magnitude of unity, so in physics, the unit vector has only one purpose to serve, that is to give direction to some quantity. See, a vector whose magnitude is unity. Okay. So what is the use of that vector? The use of that vector is to give direction to some physical quantity. So basically its sole purpose, okay, in physics, okay, is to give a direction. Sir, what is the importance to it? It is very, very important. It is very, very important. So give direction to some physical quantity, or we can say give direction to some vector, to some to vector. Just write that. Or physical quantity. Okay, but someone may say that some physical quantities are scalar also, na? So if they are scalar, they don't have the direction. You don't need to give that. But they are, if they are, if they are vectors, so direction is required. So unit vector gives the direction to the physical quantity. And see, we'll try to come up to more to it. But see, just try to think of this as one way. So this is something so important that this is given as some different denotion as well. Are you getting my point? So these are represented like this. So if you are having a vector, unit vector A, so it is represented as A cap. So they are so important that they are given a formula. Okay, they are given a formula, and they are also given a different representation. Okay, in the world of the vectors. So they are very, very important. A cap is equal to A vector upon what is this? So this is the magnitude of A vector. Are you getting my point? Okay. So we are going to see the use of it in the unit vector in the Cartesian coordinate. Okay. So like for example, you must have seen this IJK thing now. Okay. So if you want to show some, if you want to show the position of something, or if you want to represent the vector something, so you normally do it in terms of x, y, and z. So in x, y, and z, we assume some unit vector, and it helps us to describe some physical quantity completely. Understood? Understood? Okay. Like for example, see, just giving you one context, although we'll be coming to this also. Let's suppose this is x, this is y, this is z. So basically in physics, we'll deal with these three directions only. Now there are three directions. Okay. Okay, x, y, and z. And now when something, let's suppose in a space, something is here, something has moved some to some place. So like this, let me make it like this. Please try to think it. Let's see. Just trying to give it a 3D view. Now, if something is here, like for example, in your room, so I told you that there is a corner. Now, let's suppose that corner is your origin. What I'm trying to tell you, just try to think. No, it is not always necessary that from corner you move in X only, you move in Y only, or you move in Z only. In X or Z or Y, you can move in the combination of it now. So anybody, if you are moving in the combination to it, okay, so how you are going to present that vector? So you can present like this. See, normally how a vector is presented. Let's suppose there is a vector velocity. So you write 5 of I plus 6 of j plus let's suppose 9 of k. Okay, so what is these I cap, j cap, k cap? So these are unit vectors in the direction of x, y, and z. And basically, it helps you to understand this vector v in context to all these three directions at once. Okay, understood something? Because lately we are going to talk about it in much extent, but you understand the relevance of this unit vector to some extent, isn't it? Isn't it? Like for example, I tell you one thing. So you might be going towards your school, and I am very sure that by the time you reach your school, you must be seeing many arrows pointing towards some direction. Go in this direction. By 10 kilometers, you'll get this shop. Okay, there is some famous street shop, or there's some famous eatery at your place, at your city. So you will be seeing there are a lot of pointing out. Okay, this is the arrow. Now the length of that arrow, is it giving you the actual distance? No, sir. It is just giving you the direction of it. Direction. That is the work of unit vector in a way, right? Okay, so basically we are using the unit vector to present or to interpret or to give directions to something. Okay, we'll come back to this. This is something known as the Cartesian coordinate. Representation of a vector in Cartesian coordinate. We'll be talking about it, don't worry. Okay, so this much is fine, right? Unit vector. Now there is one more type of vector, that is the zero vector. Zero vector or null vector. Zero vector or null vector. Sir, what do we mean by zero vector? What do we mean by the null vector? So, sir, as the name suggests, sir, zero vector. So it is something which is having zero magnitude. Okay. So zero vector or null vector is having magnitude of zero. It is having the magnitude of zero. So zero vector or null vector is something which is having zero magnitude, which is having the zero magnitude. Okay, okay, and also it is having the zero magnitude. So, sir, what is the relevance? So, magnitude of zero. So how it could be of any use? So basically, when some vector having the magnitude zero, but it is a vector, so it must have some direction also. When the magnitude is zero and you have to give it some direction, so it can be having any arbitrary direction. Okay, so what is the zero vector? What is the zero vector? So zero vector is something which is having zero magnitude and its direction is arbitrary. Arbitrary means that you can assume it in any direction. So what is the use of it? It is useful. See, when we'll be going to the cross product of two vectors, so you must be knowing. If you don't know, just listen to me once. So we'll talk about cross product, dot product, scalar product, everything we'll be talking about. Don't worry. So two vectors, when they are having the cross product, their result is also a vector, right? Now two vectors, when they are cross product, their result is vector. So if by any chance the result is coming out to be zero, so it means that is the zero vector and it has some direction. What direction? When there is cross product of two vectors, the direction of the result to it is always perpendicular to those two vectors. So there the zero vector will have the perpendicular direction to it. So I'm just giving you the context. Okay. Okay. And we'll come to all these things soon and we'll talk about it. Okay. Okay. So now these basic things, types and everything is clear. Please answer me yes or no. Please answer me yes or no. Now, now let's go to the vector addition part. What should we say? Anything wrong, my dear? All good? All good, Bila? You said O in the chat. What was the reason for that O? Oh, you didn't know that word. Okay. We'll talk about everything. We'll talk about everything. Now let's come to the very, very important part. Very, very important part. This is something, so don't feel that you are learning vectors only. You are learning forces together. You are learning about kinematics, velocity, acceleration. Everything is taking place in one way. That is the beauty of physics. Now, that is the beauty of physics. Not like biology, right? It is a beautiful subject. So don't say like that. Her is on leave now. Okay. Please understand this. Oh, come to this. Now, please see. So now let's talk about vector addition. So let me take it. Methods of vector addition. Now I'm going to tell you it in a way that you will never going to make any mistake. Now for that you have to give due importance to both of the methods, that is graphical as well as analytical. Graphical method and analytical method. Now please understand this. Now please understand this. So basically, there are three ways. So first, we'll talk about the graphical method. So graphical method, is it important? Are we going to take some scale or pencil and all these things to the examination? Don't, just trust me. Okay. See, big questions you can do through graphical way very easily. So it is must. What normally students do, that they just memorize the formula, law of parallelogram of forces. They memorize the formula P square plus Q square plus 2PQ cos theta. Okay, tan alpha B sin theta plus A upon A plus B cos theta. हो गया काम खराब. Are you getting my point? This is not the right way to physics. Biology नहीं है. This is not biology कि बस memorize कर लिया पता कुछ नहीं. Getting my point? Physics, you have to understand each and every point. Otherwise, you will not be able to make. You will not be able to solve the question. Also, don't do that. Let's change that angle. Okay, let's change that way. Okay, so don't do that in physics. Otherwise, you will never be confident in the physics. And mind you, if you are not confident in a subject, and in the examination in which you are going to do, as having some negative marking also. So unless you are confident in some subject, you will always be, thinking that whether I should mark this answer. Seems like this is the correct, but I'm not sure. Shall I do it? Shall I not do it? You'll get trapped into that. Okay, so be careful in physics. You have to have the concept. Now please understand this. So methods of vector addition. So we have graphical method and we have analytical method. Okay, graphical method भी होता है और analytical method भी होता है. So graphical method is also known as geometrical method. This is also called as geometrical method. Okay, so basically what do we mean by graphical method? So in general, when you are adding some vector, okay, when you are adding some vector, so you are just solving the problem by drawing, okay, making drawing or using some geometry, simple basic geometry, simple basic trigonometry, right? Anything like that. So that is the way where we'll be using graphical method. And in analytical method, that means some formula. Okay, you will be building up some formula. So sir, only remembering the formula will do, it won't do, because there are many twists and turns to it. Okay, please understand this. So this is the formula thing, this is the drawing thing. We have to draw it conventionally. We have to have, set square, all those geometrical tools, but we don't require that. Just follow my lead. Now, there are three methods, okay, of vector addition. So one is the triangle law. So one is triangle law. Okay. One is law of parallelogram of forces. One is law of parallelogram of forces. Okay. And one is polygon law of forces. One is polygon law of forces. So basically, I tell you, they are not different from each other. Okay. But the thing is that where you are using the formula, in which question you must use what formula, so that you reach the solution quickly with less mistake and less calculation. Now please understand this. These first two laws are used for two vectors. When there are only two vectors, and two vectors are always coplanar. And then we'll come to this polygon law of forces. This is for more than. Normally it can also be used for two vectors, but it is normally preferable to more than two vectors. Okay, so when I write here more than two vectors, so don't you say into me in the chat that they can be applied to two vectors. Now I know that, but see, if you go, I for that I am asking you, sir, if you go to the shop, you have 10 rupees in your pocket, you bought two toffees for 2 rupees. Okay, so what is the sum? You have given the shopkeeper 10 rupees. So how much money he should return you? So obviously 8 rupees. Now for that, do you require the calculator to do that calculation? No, sir. Now, if I say don't use calculator, it is in such calculation there's no use of calculator. Polygon means polygon. Everything is polygon. Triangle is also a polygon. Quadrilateral. So having more than two sides. Okay, anything which is having more than two sides is a polygon only, right? Like we are having this is a polygon. It is having 6 sides. This is also a polygon. It is having 4 sides. This is having a polygon which is having 3 sides. Okay, so any number, octagon having 8 sides, hexagon having 6 sides, pentagon having 5 sides, all these are polygons only. Okay, so I was saying that when I write more than two, because it happened to me previously. Okay, so more than two vectors when I am writing here, I just mean that it is preferable to be used when there are more than two vectors. It doesn't mean that it cannot be used for two vectors in the same way that you can make the calculation 10 minus 2 is equal to 8 by calculator also. But would you do that effort? Bringing calculator, typing, and all this, you won't do, right? Simple logic. Now let's come to the point. Okay. Now please understand this. Please understand this. Let's suppose we are having two vectors, A and vector B. Okay. We are having two vectors, A and B, and I want to add these vectors. What I want to do, sir? I want to do the addition of these vectors. So when I'll be adding these vectors, definitely when I'm adding two quantities, there will be some result. Now in the world of vectors, this is what we call as the resultant, right? So this is the general terminology that we call it as resultant. So whenever two vectors are added, they will be having some result. That is the final solution. That will be the resultant. Now, please understand this. This resultant will also be a vector. Now, if you want to know about this resultant, you need two things about it. One is magnitude and one is direction. Always remember this. Okay? Okay? So the result of addition of two vectors is always a vector, and to define or to present any vector, you need both magnitude and direction. So what we are seeking from these laws, that we want to find the direction and magnitude of the resultant. Okay, okay. Now let's suppose these two vectors are like this. Okay, this is your vector A somewhere, and this is, let's suppose, your vector B somewhere. Vector B somewhere. Okay, vector B somewhere. Now see, now see. Let me write first of all. So let's start from here. Nikita, hello, very good evening to you, my dear. So, beta, what we are doing, we are trying to understand about the vectors. Okay, हम vectors के बारे में समझने की कोशिश कर रहे हैं. We are trying to understand the vectors, and we just started the law of addition of the vectors. Okay, so where we are doing into kinematics. We are talking about kinematics. On this channel, we are doing this physics and biology thing. Okay, and we're trying to finish the syllabus before NEET 2024 examination. And in that order, we have completed the first chapter and the second chapter, units and measurement. And we are now into kinematics. So we are talking in both the chapters of motion in a straight line and motion in a plane. Now to understand those, we are understanding into the vectors. So till now in this session, this has been, somewhat 1 hour 40 minutes from the point I have started. So till now in this lecture, I have covered basics about the vector, that what is the vector, how it is different from the scalar, then how you represent a vector, what is the general rule, what is the parallel shifting of a vector, what is the angle between the vector, what are the types of vector, and just now I have started with vector addition. And my name is Dr. Shankar Sir. I am MTech and PhD from IIT Roorkee. Okay, so you may want to continue from here, you can. Okay, okay, wonderful. Now please understand this. So let's suppose we have two vectors A and B. Now talking about, let us start with the triangle law of vector addition. Very useful, very useful, but many teachers say that this is only useful to some cases, but I feel that it can be used in many places, so we need to see it. We need to see it carefully. So first of all, what this triangle law of vector addition? So let's write the definition of the law first. So if I write the law first, so then we'll try to understand this law. So if two vectors are given in direction, if two vectors are given in direction and magnitude, if two vectors are given in direction and magnitude by, or just a moment, just rephrasing it. So if two vectors are given by two sides of a triangle, two sides of a triangle in magnitude and direction, in magnitude and direction, taken in the same order, taken in the same order, okay, then the resultant, then the resultant, then the resultant is given by, then the resultant is given by the third vector, then the resultant is given by the third vector in third vector in magnitude and direction, in magnitude and direction, taken in opposite order, taken in opposite order, okay. So this is the statement of the triangle law of vectorization. So just read it once, just give it a read. I'll explain. If two vectors are given by two sides of a triangle, so any triangle in the world have three sides, okay, any triangle in the world have three sides. Now if the two vectors are represented by the two sides of the triangle taken in the same order, taken in the same order, the resultant is given by the third vector in magnitude and direction taken in the opposite direction, taken in the opposite order, okay. Just give it a read once more. This is like the polygon law only. Just try to understand this. I'll explain. I hope you have given it a read. Now please understand this. Let's suppose we are having two vectors. One vector is A here. One vector is B here. One vector is A, one vector is B. Now you want to find the resultant of these two vectors. Now for that, you have to represent these two vectors in magnitude and direction by two sides of the triangle taken in the same order. Or sorry, it is getting too complicated. Now please listen to me. Leave all this. What you have to do, you have to join one vector from the head of the other vector. So that is why it is head and tail method. This law and polygon law are head and tail method. So you draw one vector. Now you know you can do the parallel shift. Okay, so this B you parallel shift and start it from the head of the vector A. Okay, now read this statement. So two sides of the triangle in magnitude and direction taken in the same order. So here A and B are in the same order. Na? If you try to give it a rotation, so if you follow the arrow, it will give you the same sense of rotation. Okay, okay. So if two vectors are represented by two sides of a triangle in magnitude and direction taken in the same order, it just means that you are making the second vector from the head of the first vector, and it is your liberty that whichever you want you can take as the first vector, no problem at all. From here it will be extended to the parallelogram law also. So I hope this is fine. So you have this vector A. Now you have given this parallel shift to this vector B. You brought it here. Now the resultant of this vector will be given by the third side of this triangle taken in the opposite order. So taken in the opposite order means that it is going to be in the opposite order of that of the A and B. So if you try to feel in this triangle, what is happening? what is happening? So A and B seems to be in the same order, and you see R is in the opposite order. Is it fine? Okay. So simply in triangle law, what you have to do, whatever two vectors you are having, you join them in a way that the tail of the second vector starts from the head of the first vector, and then what you can do, you join the tail of the first vector to the head of the second vector. That's all. Clear? Yes or no? How we have drawn it? Please answer me. Yes or no? Yes or no? Please answer me. Okay. Now, if we want to do it more conventionally, so let's suppose we are having a force that is of 10 Newton in the east direction, and we are having some force of, let's suppose, 7 Newton in northeast direction. This is northeast direction. So now how you are going to find the resultant using the graphical method? So we are talking in the graphical method now. So see how you have to do it. What is the right procedure? What is the conventional procedure, I may say? Now, in this case, what happens? So you take a suitable scale. So for example, we consider, let's suppose 1 centimeter is equal to 1 Newton. So 1 centimeter is equal to 1 Newton. So you take out your scale, you draw a line equal to 7 centimeter, which, sorry, 10 centimeter, which is equal to 10 Newton, obviously. Now, from the head of one vector, you start the second vector. And let's suppose this angle is theta. This is, let's suppose, 60 degree. So what you are going to do? So this 7 Newton you shifted parallelly, and you started from the 10 Newton. Okay. Okay. So this is the angle 60 here. This is the angle 60 here. Now what is going to be the resultant? So it is given by the third side of this triangle joined in the opposite order. Okay. So see, when you are making this line of 60 degree, you measure 7 centimeter on the scale, and using the protector or D, you mark 60-degree angle, and you draw this vector. Now when you do that, when you, this is 10 Newton, this is 7 Newton. Okay. So think that you are doing it with the help of a scale, D, everything. Now you have the scale with you, so you can, from this point you can join here, and then from the scale you can measure it. So if by measuring you get, I don't know, I have made the calculation just randomly. If I am saying that you get, let's suppose, 11 centimeters, so that means that the resultant is 11. And from the D you are having, you can measure this angle, right? You can measure this angle. So now from here you get the both the thing, magnitude by measuring the length of this resultant, and alpha by measuring this angle. You get both the things now, the magnitude and the direction. Do you agree or not? Please answer me. Do you agree or not? Please answer me. But sir, are we going to do that in the exam? No, 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 no. Just try to understand the method first. Then we'll manipulate it. See, this is how physics goes. Yeah, anything, anything. We are not interested in that right now. In the value, I'm not at all interested right now. I'll give you multiple chances to get the value. Just try to understand the method. See, I have a philosophy. So first, if you want to play with the physics now, you have to understand the concept. Now later you will see we'll rotate it like anything. Are you getting my point? But for that you have crystal clarity. You have to have crystal clarity that what is it, from where to where, what to join, or it is, if it is given in that way, what is going to be there. Okay. Now, so after you have done it, you get the magnitude of it, okay, and you get the direction of it. So if I say the direction of it, so how will you give the direction? So you will say alpha from 10 Newton, right? Okay, so you will be able to do that. Okay, now let's see some more. Now let's suppose, just not taking the value anymore. Let's suppose we are having A and we are having this B. Okay, okay, and let's suppose this B is at Ryan. Welcome to the session, my dear. So there is one vector A here, there is one vector B here, and this vector makes an angle of theta like this. Now, can you draw the resultant of it? Just draw it. Just draw it in your copy or think in your mind, whatever you feel to do. Okay, just I want to see if you can do it or not. give me in the chat that done. I don't want the direction. I don't want any numerical value. Just you draw it in your copy. I just want to see that whether you are able to apply this triangle law or not. Just give me done. That's all. Then, Sayan, what about you, my dear? What about you? Done. Wonderful. Now let me do it. So very, very simple, sir. What we can do, sir. This is one vector A. Through parallel shift, we can bring this B here, and this angle would be theta. Okay, this angle would be theta. Okay. Now, so the resultant is given by the third side taken in the opposite order. So this is going to be the R. So we can measure or we can use some geometry here alpha. Okay, and we can do some geometrical calculation to this R and we can get both of it. So we understand the law of triangle of forces. Oh, sorry, vector. Okay. Okay, so this is also used why I said triangle of forces. So when we go to the forces part, now we'll be applying this only. Just one thing will be changed that in terms of vector, we'll be calling it force. So we are doing so many chapters together. So let's do one question. Let me think of one. Okay, so let's say a boy moves, a boy moves 3 meters towards east, okay, and then took 90-degree left turn and moves कितना चलाएं चलो 4 चला लो 4 मीटर towards the north towards the north okay towards the north find the displacement find the displacement now before I give you the option to this question I want to tell you something actually this is an advice so see this is a very popular triangle are you getting my point let's suppose here this is 4 so it doesn't look like that don't worry I'll just make it like this okay let's suppose this is 3 this is 4 this is 5 okay so my recommendation is you memorize the angles here okay so see this is 30 sorry this is 53 and this is 37 are you getting my point beta okay okay so I told you this before as well I guess okay just giving you a reminder right okay right so just one second let me check once है ना it is always to check right it is right okay. Wonderful now please understand this now please understand this so we are having this like this okay okay so let's have the question so I'll just give you the options here so it is options are 5 meter and 53 degree 5 meter and 53 degree yeah 5 meter and 53 degree east of north 5 meter and let's say 37 degree east of north then we have let's say 5 meter 37 degree west of south and 5 meters this is a question actually from the PYQ so see no one is interested in the 5 meter are you getting my point please say please observe please observe please do it you are saying some A, B. And what about you, Sayan? Can you please try this question? Just take your time, no worries. And see if I have some another good question for you in this context. Please answer. Please try to do it. So how we can do it? Let me. Okay, first you give the answer. Please try to solve this one. First you must try to answer it. Then I'll do. A, your last. Okay. What about you, Sen? Do you have any answer to it? Okay, I'll do it. Sen, do you have any answer? Would you like to answer it? Would you like to answer it, my dear? Okay, I'll do it. I'll do it now. So now a boy moves 3 meter east. So this is displacement, right? Vector is there. Why, sir, it is displacement? Because direction is also mentioned. So you are moving 3 meter towards east. Then it took left turn 90 degree. Yeah, that is why she say in the starting now. So many students say to me, sir, why you are saying north, east, east, north? Because that is at that point also I said now. So this seems to be very simple. So northeast, okay, northeast, east of north. But see, when you have to apply it, so many times it gets confusing. Don't worry, don't worry. We are going to do that. Don't worry. So we have this 3 meter. Okay, so we are moving 3 meter towards east, then took 90 degree left turn and moves 4 meter towards north. So when we are moving 4 meter towards north, so it will be like this. Now we have to find the displacement. We have to find the displacement. So basically displacement. Okay. Now please try to think in this way. Okay. See, someone has moved to some distance in some direction, then he has moved in some distance in some other direction. So what is the resultant of these two? That is the resultant of these two is called as the displacement. Are you getting my point? Okay. Are you getting my point? So what is the resultant to it? So sir, one vector, then we have started the other vector. So head to tail we are joining, or we are using the triangle law. Okay. Yeah. So now please, what we have to do? So your answer is wrong, Shrita. This the answer is not A, my dear. Just let me solve it. Let me solve it. So this is 3 meter, this is 4 meter. Now you understand that this is the resultant. This is the resultant, and this is your standard triangle. If this is 4, this is 3, this is 90. So we can use simple geometry, no formula is required, and this is going to become 5 meter. This is going to become 5 meter, and this is going to be 53 degree. 53 degree. So when this is 53 degrees, see the options, guys. This is going to be 37 now. This is north, but you said that is your final answer. This is northeast. So when it is written EN, so it means east of north. Sorry, it is east from north. How we read it? East from north. Okay. So we measured from the north towards the east. So when we measuring from the north towards the east, the angle is 37. Is that clear to you? Please answer me. Is that clear to you? Right? Yeah? Please answer me. Good to go? Wonderful. Now, let's move to the law of parallelogram of forces. Okay, extensively used law, and this is going to give you a formula also. That is also we are going to see. Just uh, yeah, don't get confused. Okay, so law of parallelogram of vectors. Okay, sometimes I say forces, don't mind that. Okay, because I am a mechanical engineer now, so like forces, always forces in my mind. Okay, so instead of vectors I sometimes say forces. I hope you don't mind that. Forces are vectors too. Now, talking about the forces, so now from where this law of vector of parallelogram, so I'll just give you some context. So let's suppose body, we have a body, okay, and this body is being pulled by two directions by someone. So someone is pulling it here, F1, and someone is pulling it here, F2. Now, I think you would be able to realize this fact that this body will be moving in this direction. This body will be moving to this direction. Okay, don't do that. Okay, no problem, she said. Now, if these two are F1 and F2, if two forces are acting in this direction, F1 and F2, do you realize that this body will be moving in the direction in which I have made this R? Do you agree? Very, very simple. Do you agree? Yes, sir, we do agree to it. We do agree to it. So basically, what is this? So what is this R? This is R is the resultant to the force F1 and F2. This R is nothing but the resultant to this force F1 and F2, my dear. Okay, this is the resultant of this force F1 and F2. Are you getting my point? Are you getting my point? Because see, any body always move in the direction. Or okay, Bima. I hope you are following everything now. Any doubt? Feel free to ask me at any point of time. No, no worries at all. Okay. So this body is going to move in the direction of the resultant of these two forces. Okay. So obviously the resultant will be here. Now from here you can converge to the law of parallelogram of forces. So let's suppose, please understand this. So see, I'll make the statement. I'll make the statement, but before that, let me give you the law. So let's suppose we are having two vectors A and B. Okay. Now remember, whenever you are applying the law of parallelogram of forces, whenever you are applying the law of parallelogram of forces, you need to join these two vectors tail to tail. Tail to tail. This is why it is also known as tail to tail method. Okay. So these two vectors are to be joined tail to tail. Are you getting my point? Now, if you want to join them tail to tail, so obviously you can do the parallel shifting. You can do the parallel shifting. So whenever you are applying the parallelogram law, the first thing, join both the vectors whose resultant you intend to find, you join them tail to tail. So when I join them tail to tail, I can take B here, I can take A there. So when we take this B here, it B will be like this. B will be like this. Okay. Okay. Then you complete the parallelogram. So what is the parallelogram, sir? So in parallelogram, two sides are equal and opposite to each other. So A is opposite to this one and will be equal to this side. And similarly, B will be equal and opposite to this side. Equal and parallel to this side, not opposite. Right. So we all know to make the parallelogram. Now, according to the law of parallelogram of vectors, first of all, you have joined both the vectors tail to tail. Okay, then you have completed the parallelogram. Then the resultant of these two vectors will be given by the diagonal of this parallelogram, and that diagonal must start from the point where these two vectors are meeting tail to tail, that is starting from the intersection of these two vectors. That is just the law of parallelogram of vectors. Is it clear? Is it clear? I'll write the statement to it. But till this point, it is clear? Yes or no? Please answer me. Yeah. Please tell me. Okay. Okay. So see, in the triangle law, and this is nothing different from the triangle law. See, please understand this. So you see the similarity. So see, parallelogram law, triangle law, they are not different to each other. They are same only. How they are same? Now B is here. If I say that B is here also, so that is not wrong now. Now if you feel, if you don't see this, just don't see this. If you see only this part, R, A, and B, this is from the triangle law only. Now A and B are in the same order. R is in the opposite order. Okay. If the magnitude and direction of two vectors given by two sides of the triangle taken in the same order. The resultant is given by the third side taken in the opposite order. So if you see this RAB, this one, you are going to feel that this is nothing but the law of triangle of forces. Okay. So law of triangle of forces twisted to something and made the parallelogram law of forces. So again, in parallelogram law of forces, you have to join two forces, two vectors. Again, I'm saying force, two vectors tail to tail. So whenever you are joining two vectors tail to tail first thing, then you complete the parallelogram. Then there will be obviously two diagonals in the parallelogram. So the diagonal, which one is emerging from that combined tail of these two vectors, will be giving you the resultant of the vector. Okay. So you get the resultant. What else you need? So we need the direction also. So we are talking graphical way. So you can take up the D. You can measure this alpha also. So this alpha is given from the vector A. Alpha is given from the vector A. Is it fine, my dear? Yes or no? Okay. Okay. So let me write the statement to it. So basically, the law of parallelogram of vectors says if two vectors, if two vectors are represented by, if two vectors are represented by, if two vectors are represented by two adjacent sides, two adjacent, if two vectors are represented by two adjacent sides, okay, two adjacent sides of a parallelogram, two adjacent sides of a parallelogram, okay, in direction and magnitude, in magnitude and direction, in magnitude and direction, then the resultant, then the resultant is given by, then the resultant is given by the diagonal, the resultant is given by the diagonal of the parallelogram, given by the diagonal of the parallelogram in magnitude and direction, in magnitude and direction is starting from, in magnitude and direction is starting from common intersection, common intersection of, common intersection of two vectors. Okay, so this is the statement to it. I hope it is clear to everyone. Yes, give me yes or no. Is the law of parallelogram of forces clear graphically? Yeah. Yeah. Can you please tell me? No, please understand it. So if we, so well, okay, this is clear. Wonderful. So let's solve. Let's take some, questions for our better understanding. So we understand, we interpret this thing better. Okay. So first we'll go by graphically, and afterwards I'll start with analytical. Analytical means I have to derive some formula to the same thing. So let's try to apply it. So vector A, what happened? Vector A has a magnitude. Vector A has a magnitude of 10 units. Vector A has a magnitude of 10 units. Okay. Okay. And point due west. And point due west. Okay. So vector A has a magnitude of 10 units and it points due west, while vector B, while vector B has a, while vector B has a same magnitude, magnitude same ही रख लेते हैं, have a same magnitude and points due south. Points due south. Okay, points due south. Find magnitude and direction of. Find magnitude and direction of. Find magnitude and direction of vector A plus vector B and vector A minus vector B. Okay, please go for it. Please go for it. I'm very sure we can do it. Correct. What you have to find? You have to find. So, lot of things we are going to learn from here. Please go for it. No, no. Unit 10 units is given. No, magnitude is also given. So this is the magnitude you are saying. Or direction. डायरेक्शन आप बताएंगे फाइंड मैग्नीट्यूड एंड डायरेक्शन तो डायरेक्शन आप बता दीजिए ड्यू वेस्ट से फ्रॉम ड्यू वेस्ट ओके वेस्ट से डायरेक्शन बता दीजिए चलिए प्लीज गो फॉर इट प्लीज गो फॉर इट all the other live students also may respond to me on this all the other live students may also respond to me on this 45 degree. This is how you represent the direction, my dear. You must tell me in the north of west, south of west, east of west, anything like that. Okay. So you are telling for A plus B or A minus B. And what about the rest of the students? You may also please answer me on this. A plus B. Good. What about the other one? See, there are a lot and lot of takeaway points from this very question, which we will be using to save some time in bigger questions. East, west, northwest. Which one to believe? Northwest. 45 degree northwest. Okay. Okay. Now let me do it. Now you have solved this question, but still I want your 100% attention to this question because see, as I always say, na, in NEET examination we have limitation to time also. Okay, we have limitation to time also. Now, when we have the limitation to time as well, when we are having the limitation to time as well, we have to be careful. We have to be careful that see sometimes what happens that using these hacks, a small information save big of your time. Okay, now please understand this. So vector A has a magnitude of 10 units and its point due west, while vector B has the same magnitude and points due south. Okay, so vector A is having the magnitude of 10 units and it is pointing towards the west, and vector B has the same magnitude and it's pointing towards the south. Okay, so both vectors are the same. Now when they are saying A plus B, you have to find the resultant. You have to find the resultant. Now please understand this. So this is 10, this is 10. they are already joined tail to tail. So you can apply the law of parallelogram of vectors, or you can apply the law of triangle of vectors. Both are more or less the same only. Both are used for the two vectors only. So this is 10, this is 10. So this is going to be the resultant, obviously, because when you make the parallelogram, so not always you require to make the parallelogram. See, if we have to save in some time, so initially we are doing, so see what happens. We have made both the vectors. We have made both the vectors, and when we have made both the vectors, we can make the parallelogram. It will look like this, and then we can draw the resulting. Then we can draw the resulting. Okay, okay. Now please understand this. Now please understand this. There is one information that I want to give you here. Now, when there are two vectors, please understand this. When there are two vectors, and they are equal to each other. Two vectors which are equal to each other in a magnitude. Okay, they are not equal vectors, but they are equal to each other in magnitude. So two vectors having the same magnitude, their resultant will be exactly in the middle of these two vectors. So for example, if this angle is theta or this angle is 60, this will be 30 and 30. If this is 90, now right now it is 90, so this will be 45 and 45. So remember this thing, this will help you save some time lately, that whenever two vectors are there and the angle between these two vectors is theta, okay, and those vectors are exactly having the same magnitude, then the resultant of them will be exactly in the middle of the angle between them. Right? It is quite obvious also, isn't it? Okay? I hope you remember that. So see, direction is sorted. Direction is sorted. So this is 45. From here also it is 45. Now what about magnitude, sir? What about magnitude, sir? So if this is 45, this is 45, this is 10 also. This is 10 also. Now this is 10, this is 10. So let's apply the Pythagoras theorem. So this 10, this 10, this is going to be 10 root 2. Okay, do you need to apply any formula here? Okay, so R is going to be 10 root 2, isn't it? By the Pythagoras theorem. So how you are going to solve it? So it is going to be 10 root 2, and now see the direction. So it is in southwest, isn't it? Is it in the south of west? So we have to give the solution due west. So 10 root 2, we must write 10 root 2 south. Only south will suffice. Why only south will suffice? Because due west is written here, na? So what is direction? 10 root 2 south. So that means south from west, because west is already written, right? But if you want to write the whole thing, you can write the whole thing. So that is south from west. Understood? But remember, if this kind of a question may come in the examination with some option, it will be written only south. Then don't think that this option refers to this, because west is written there in the question now. So only south is also written here. That means that you are seeing the direction due south, due west. So from west it is south. Understanding my point? Yes or no? Please answer me. Wonderful, sir. Wonderful, sir. Now let's talk about A and B, A minus B. Now please think, please understand this. You will get some concept here. Very, very important concept here. Very, very yeah, Shita, it happens. It happens. Okay. It is common problem. Okay. Now please understand this. So we have this A. We have this A. Please see this. So we have this A. This is 10. This is 10. Now this is minus of vector B. So this is vector B, right? This is vector B. So now minus of vector B, my dear, minus of vector B is going to be opposite of this 10. This is minus of vector B now. Okay, so can we write it as this A plus minus of vector B, right? These two are the same thing. So basically you are finding the resultant of this one and this one. Are you getting my point? Are you getting my point? Now here, please observe. Here, please observe. So you have the resultant. So two vectors. Now we have nothing to do with this. Now two vectors, they are same in magnitude. So their resultant will be exactly of the middle of them. Okay. So the angle is 45. So it will be, the resultant will be, so again we can complete the, parallelogram. So the resultant will be 10 root 2. The resultant will be 10 root 2. Resultant will be 10 root 2. And it is north of west. Okay, it is north of west. Do you agree or not? Please answer me. Please answer me. Here you will get some relevance of subtracting when two vectors are subtracted. This is not subtraction, this is addition only. We are using the law of addition of parallelogram. So this is addition only, my dear. This is no subtraction, this is addition. Addition between two vectors. Now here, this is one vector 10 in the west and this is one vector 10 in the north. Two vectors are, when it's minus sign is written, it is not subtraction, it is addition only. We are using the same law of parallelogram of addition, or we may use the same law of addition of vectors using the triangle law. Is that clear? Please answer me. Is that clear? So just give me yes or no if this is clear. So I'll just give you some more points here. Okay, some more points, some more takeaway points. Wonderful. Now please understand this. Now we have one thing we come to know, that two vectors, okay, there may be any angle between these two vectors. If they are both same in magnitude, so their resultant will go exactly in the middle, from the middle of it. Okay, so if this is 60, this will be 30, 30. So I'll write theta by 2, theta by 2. I hope it is fine to you. Okay, yes, Bima. Okay, now please understand this. Now please understand this very, very important thing. Now, what you observe from here. Now see, again you can get this feel that how vectors are different from the scalar. Okay, see, two vectors added, two vectors added, okay, they are, when two vectors added, in this particular case, A and B, they both are having the same magnitude, okay, like this. So in a scalar, is it possible that you are subtracting two quantities, you are adding two quantities, their solution is same? So this is not possible. So in this case, they are having the same magnitude. In this case, they are having the same magnitudes. Are you getting my point? So two vectors, once they are added, other they are subtracted. Although there is no subtraction, but it seems like subtraction. Okay, so two vectors added and two vectors subtracted. There is nothing like subtraction though. But it seems like subtraction. Two vectors added and subtracted giving the same result. This is only possible in the case of vector. Are you getting my point? This is only possible in the case of vector. Understood, my dear? Please answer me. Please answer me. Now, how they ask you, how they frame question in the examination from this. So they ask you, if vector A plus vector B is equal to the magnitude in vector A minus vector B, the angle between A and B is. The angle between A and B is. Okay. Okay. So 0 degree, 60 degree, 90 degree, 180 degree. Can you answer me this? Yeah. Yes, you can prove 2 plus 2 can be 4, can be 5, can be anything. I'll come to that also. Please answer this one. Please answer this one. Very easy, isn't it? So one way you do by the formula. Now many students do use the formula, then they say that cos theta is equal to 90, but right away you know now, two vectors, when they are added and subtracted having the same magnitude, only it is possible when the angle between them is 90 degree. When the angle between them is what? It is 90 degree. I hope it is clear to everyone. So what is the option? Right away we can mark C. Bima, what is your take on this? What is your take on this? Please answer me. Now let me give you one more point. Now, sir, we came to understand one fact that the angle between two vectors will always be between 0 to 180 degree. Will always be 0 to 180 degree. And we started with 4 and 3. We started with 4 and 3. So let's suppose we have a vector that is 4 and we have a vector, let's suppose A, we have a vector A that is 4 in magnitude, okay, and we have vector B which is 3 in magnitude, and the angle between A and B is 0. The angle between A and B is 0. Okay. Now, in this case, do you realize that when we are applying the law or when we are making it, so we make it like this A and then it is going to be B. You are joining them tail to tail. You are joining them tail to tail. Yes or no? Yes or no? Now, if you are joining them like this, do you realize that when we are adding these vectors in magnitude, since they are in the same direction, need not to apply any law here, you can say A plus B is equal to 7 in magnitude. What do you think? Yes or no? Now, similarly, if we say that the vector A and B are having 180 degrees, so you can see it from the formula. Okay, when I go by the analytical way, I'll give you the formula. I can do by the graphical way also, but for that I have to take some, I'll have to give you some more sense to it. So don't do that. You simply know that two vectors in the same direction can be added directly, their magnitude can be added directly, and we can do it by the formula also. Now, and I'll do it by the formula also. Just giving you a common thing. Now, A and B, the angle between A and B is 180. So we can write it like this 4, and we can write it like this. That is 3. Okay, that is 3. So A and both are in the opposite direction, and the angle is 180. Now in this case, the magnitude is going to become difference of it in difference of it. Please answer me. Do you agree to it? Yes or no? Now, do you feel here that are when two vectors are added, so this is also addition. This is also addition, isn't it? Here, this is A plus B. I mean, I have to write A plus B. Sorry, didn't write A minus B. I have to write A plus B. This is also addition, no? We just know, we just came to know. This is also addition. So that is why I have written that when you are adding two vectors, it can be anything between 1 to 7 in the case when vector is, in the case that vector is having the magnitude of 4 and 3. So that is why in the beginning I told you that when two vectors are added, their resultant or their solution to this addition can be anything between 1 to 7, unlike the scalars. Is it clear? Please answer me. Right? I'll be showing you with the analytical way also. Don't worry. Okay. Now, is it clear till this point? Shall I move forward a bit? So let me complete the graphical way. Let me complete the graphical way. So I'll be doing the analytical way. No, 2 plus 2 cannot be 5. Are you getting my point? 2 and 2 cannot be 5. It can be anything between 0 to 4. Right? 3 plus 2 cannot be 6. It can be anywhere between 1 to 5. Right? Okay. There are so many questions on this also. We'll come to it. Don't worry. Okay. We just have started in the vectors. Na? All these basic things. Okay. Now please understand this. Okay. This is clear now. Now let's come to the polygon law. Okay. After that, I'll derive the formula. Okay. Polygon law of vector addition. Polygon law of vector addition. So it is normally used, okay, although it is not necessarily, but it is normally used whenever we are having more than two vectors in the system. So let's suppose we are having vector A, we are having some vector B, we are having some vector C, we are having some vector D, and their angles are also given. See, very, very simple. So this is also known as head to tail. Again, you have to use head to tail. So I'm not going to give you the statement here because it is very, very simple. I hope you got it. Nobody is going to ask you the statements in the examination. Now, in this, you have to move by head to tail, head to tail. So that means you draw a vector. From the head of the vector, you draw another vector, that is B. So how to make the parallel shift? Now, I hope you understood. If this angle is theta, this is also theta. Parallel shifting we are doing. So this is we have done already. So this is A. From the head of one vector, you started another vector. Then C, parallel shift this C. So when we shift this C parallelly, it will be here. Then parallel shift this D. So when you parallel shift D, it will be here. Okay. So these all the vectors. Now please understand this. Very, very simple. Almost like the triangle law. So here what is happening? Here what is happening? See, all the vectors are in the same order. A, B, C, D. Do you see that they are all in the same order like the triangle law? Right? Because you have head, tail, head, tail, head, tail, head, tail you are doing. So what is going to be the resultant of these vectors? So the resultant of these vectors will be given by the final side of the polygon, taken in opposite order. So this is going to be the resultant. You can see the magnitude if you are doing it graphically, and you can see the angle by using the D. Is that clear? Very, very simple. Is there anything in this? We are not going to do any questions or anything on this. Okay, very, very simple. Isn't it? Very, very simple. Okay. So normally it is going to happen in a graphical way. Okay, so when there are more than two vectors, are we not going to find the resultant or anything? We'll do everything. Don't worry, we'll do everything. Okay, but we'll do in the way which will be quickest, which will be easiest, which will be less space consuming. Are you getting my point? Okay, is it clear? Okay, now let's talk about a few more things. Okay, I hope we can continue for let's say 10-20 minutes more. Yeah. Okay. Just okay. Just last few things. Okay, I'll start with the derivations and the formula thing, because see, right now in this section we have done all the basic things how we do which normally we many know, right? So analytical thing we'll do in the next session. Will that work? Fine. In the next session means mostly tomorrow. Okay. Okay. So now please understand this. Let's conclude the today's session. So now please understand this. So vector addition. There is one thing. One is statement. So vector addition is associative. Now what does that mean? See, vector addition is associative. Very simple. In the way already you must have observed this. Okay. Yes, Shishari. So vector addition is always associative. So that means simply if we have three vectors, let's say A, B, and C. So we can write A plus B plus C together. Okay. And this is also equal to A plus B plus C. Are you getting my point? They both are the same thing. So vector addition is associative. Clear? Vector addition is associative. So A plus B plus C is equal to A plus B plus C. Okay. 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 Clear? You want to see how it happens? So let's consider we are having a vector A, then we are having a vector B, then we are having a vector C. Okay, so let's have some vectors. Very easy, na? Vectors A, B, and C. Okay. Now, what is going to be the resultant of it? So the resultant will be this, right? Law of polygon of vectors. So the resultant is going to be this. Okay. Now, when I write B plus C, do you realize that the resultant of this B plus C? So these are two vectors. You can apply the law of triangle. So this is the resultant of B and C, na? So can I write this as B plus C? Right? Yes or no? Yes or no? Wonderful, sir. Wonderful. Now you check. A and B plus C. So B plus C itself is a vector. Isn't it? This is the resultant itself is a vector. So A, then the resultant of B plus C, this itself is a vector. So that means you are adding this vector A, then the resultant of B plus C. So the resultant of this thing also is going to be this R. Do you agree? See, this has happened to be a triangle A, B plus C. So if the magnitude and direction of two vectors are given by, if magnitude and direction of two vectors is given by two sides of a triangle taken in the same order, then the third side is going to give you the resultant of it. So A, B plus C. So the resultant of it is going to be the third side of this vector, the triangle, that is the R. Now please think, what is the resultant of this A and B? So what is going to be the resultant of this A and B? What is going to be the resultant of this A and B? So the resultant of this A and B is going to be this now. Please observe. So I'll just use orange color here. So do you feel that A and B, the resultant of this A and B is this only? This is A plus B, isn't it? This is vector A plus B, right? Okay. Now this resultant, so how you have taken this resultant? See A, B, see this triangle, this one, this triangle. Okay. Now in this triangle, please observe A and B are representing two sides of the triangle. So third side, A plus B is taken opposite. Okay. Yeah. Line from that way also we do. Okay. So this is A plus B. Now A plus B, then this C. A plus B, then this C. So this is one more triangle, A plus B, then C. Then again the resultant is R only, na? Right? So either you go A, then B plus C, you are getting the same resultant. If you are going from A plus B to C, you are going to get the same resultant. Is that clear, my dear? Please answer me. Please answer me. Yeah. Please tell me. Yeah. Now one more thing. I hope it is clear, right? So vector addition is associative. Wonderful. Now let's talk about it. So one more thing. Vector addition. Vector addition. So you have to remember it, and lately we'll be using it also. Vector addition is commutative. Vector addition is, yeah, we just say vector addition follows commutative law. Vector addition follows commutative law. So what does that mean? So vector addition follows commutative law. So that means A plus B is equal to B plus A. Okay, so if you do A plus B, you do B plus A, they are the same thing. I hope in our journey you understood that only. Na? If this is A, okay, and this is B. If this is A and this is B, so we can make A here, okay, we can make A here, okay, and this is the parallelogram. So we can have this A plus B is this, right? This A plus B is this. Very, very simple. Very, very simple. Okay. So this is going to be the R. Now, if I write, so this is B, this is B, and if I say this is A, this is A, okay, then again this is going to be the, when you use the law of triangle and you draw the parallelogram, so same thing only, na? Same thing only, na? So I'm not making the parallelogram because they are not connected tail to tail. But you can see, you can observe that both are the same, right? Both are the same, isn't it? Please answer me. Okay. Okay, so vector addition is also commutative. It follows the commutative law. Vector addition is associative. Clear, my dear? Right? So I think we can keep it to this point in this session. So in the next session, I'm going to derive the law of parallelogram of vectors for you. Okay, and then we'll be solving multiple examples first from both vector addition and subtraction, which is there is no subtraction. I just have shown you. Okay, and we'll solve multiple examples. We'll get and we'll do uniform circular motion questions also right away within this only. Okay, okay. So we are taking it with a speed. Okay, and then we have in kinematics, we have to understand the graphs in kinematics. So after now vector is completed, because we have taken one good stop in motion in a straight line, then I'll finish the vector first. I think it will take one more session, one or two more session hardly. Okay, and afterwards we'll start with the graphs. Okay, so that will be all in this session, guys. It has been a long session for you guys maybe also. So those who are watching the recording, please subscribe the channel. Those who are watching, please like the video, please subscribe it, please join the channel. Okay, okay, so thank you, Shishai. Okay, so with this, let's keep it to this point. Thank you very much. Have a good day, and we'll see you in the next session.